And now we're going this. This is Mark from the Engineering Heretic, and we're to the final stage. We've cut the 5 holes in the PCD. We've done the circuit pocket milling for these 2 holes here, and we've cut our slots. And now we're going to free this part from its plate. And before, it's been most likely clamped down onto a milling table from clamps from the outside, and all the milling's been done in here. And now we're going to cut around this outside profile and free this little component so it lifts out of the job, and then the milling will be complete. Now, let's just have a look. First of all, we need to discuss a couple of things about milling around profiles and around things. NCplot does have a DXF thing here when you can make a DXF file and supposedly mill to that. I've tried it. I can't get it to work. The lines go all over the place if you do it developing in CAD. But we're going to just program this quite laboriously. Now, to do this, we do need to have the intersection points of the arcs here. So I've done the dimensions in my CAD system Libre and made up a drawing. So we have these intersection points that we do need to use. We're going to start our cutter off the job over here somewhere, a ½ an inch off the job here. We're going to come across here. Then we're going to sweep, we're going to turn on what I think called cutter compensation. We're going to come across here, turn on cutter compensation, and once that's on, I'll explain why we do that, and then we're going to swing around here. Now, the reason why we can't just come in and turn cutter compensation on and come to that point there is the cutter will travel from that point there to around about this point here and leave a little scallop. When this is all finished, it's going to leave a little scallop around here on the job. So we want the cutter to end up at that point there on the center line with the cutter compensation on. So that's the little dance we're going to do. You'll see why down the track. But it needs a little bit of an explanation in NCplot to make this all work. So I'll just zoom back a little bit here and get this a little bit, we'll go all, oh no, there we go. So, that's a shocking zoom, isn't it? Let's see if we can fix this up a bit. There we go. Come in a little bit closer. There we go. Now, let's go to NCplot. And I've got I've just saved my old drilling one, and I've called it outer profile, 1/4 inch end mill, and we've done our regular stuff. We've done G54, G90. We're going to change this particular one here. It's in the, we've gone to X and Y from the home position. We've got Z20, we're going to X and Y0. I want to take off the this X1 here and alter this one here, because what we want to do is be the radius of this, which is 0.42. No, it's not 0.42. It's the radius is 0.932 plus another ½ an inch. So let's do that. We'll get our cutter to that point there. So the Y is correct. It's the X. It needs to be, we're going back this way from the X, which is going to be negative what's our figure? Negative, go back out of there, backspace, 1.43. I think that should be right, and we'll update that there. So we'll go into this and have a look here, and we're at the 1.3 position, and we're going to feed down. At the moment, we're just going to put an M30 command in here, just so we don't see this rubbish at the end of it. An M30, that will take this rubbish off the end of it. There we go. And of course, we've still in the GOO. We've turned our cutter. We've put the height comp. We set our tool height here. Speed's 500. Feed rate's 1 inch. That'd probably be reasonable. We can always change it down the track. and we've turned our cutter on. Now, what we want to do is to feed down, we need to come down to x negative 0.25. We need to be in G01, which is linear interpolation, 0, 1, Z negative 0.025. So we're going to go into the surface of the plate by 25 thou. So we'll update that there, and you'll see a little bit of a line appear down here. And now we've got our cutter down into the job. The spindle's running at 500 RPM. Now, we want to do cutter compensation, and we want to be, now we're going to, a little bit more of an explanation on the job itself. We're going to go around this way, climb milling around our profile in that direction. So we're going to come over here. So we want our cutter to arrive on the, if you come on the left-hand side with here, we want the cutter to arrive on the left-hand side of this here. So on this, so if you can look at a line through there and then sweeping down here, we want that cutter to be on the left-hand side of that, sweeping around here, because it's always, if the cutter's going in that direction there, you'll see it. We want it to compensate on the left-hand side. So we'll go to NC plot. We want to G01, but we want to do a G41. And that is cutter compensation to the left-hand side. We want to P value, which is the radius value of 0.2 it's a quarter cutter. It's a quarter cutter. 0.15. 125. That's the radius of the cutter, and we're in G01. We already are in G01, but I'll put it in again. It doesn't really matter. 01, and we want to travel to Y to the Y negative 5. So it's Y negative 0.5 inches, and we'll turn that on there. Now, we have come across here. We'll just view this from the top here. We've come here. Our cutter is central here, but it doesn't show it on the screen there. But by the time it gets to that point there, the cutter will be, is it on the left-hand side? We're compensating to the left. I think this is right. If it's wrong, you'll see it on the mill straight away. We're compensating to if it's coming down here, it's to the left-hand side of the cutter. So I might be wrong here. It might be the right. If it's G41, G42 is cutter compensation the other way. But it doesn't show up on here. It just shows a straight line. So it's just linear interpolation down to here. And now we want to do a G03. Now a G03 is an arc, and it's an arc sweeping around to about that point there, and of course then we're going to sweep around to the other side around following the profile. So we're going to go a G03. The next line is an arc, G03. We want to arrive at that point there, which is on the edge of our part. We want to arrive at this point right here with that cutter compensation on. Now I might be wrong with this cutter compensation. I'm pretty sure it's to the left-hand side of the part. I think that's right. We want to arrive at X. Remember, we're in absolute. We're in G90. We're X negative 0.93, which is exactly the radius of that part there. So I don't have to worry about the cutter radius or allowing for that. Otherwise, I'd have to subtract 125 thou off that and have it coming over here. But I don't need to worry about that because the cutter compensation takes care of it. And we want to also arrive at Y0. 0 decimal point. It doesn't really need a decimal point, but we'll put it there. And we also need to put in the radius of this arc, which is a half-inch radius. So we put in R for radius, 0.5. And we'll hit this here. And it'll do a rather strange looking thing. It's swung around here. It's gone from there. You need to stipulate the start point, it's at the start point, the end point of your arc, which is now that point there, and the radius, which is 0.5. So that means our cutter will now be rotating here, spinning around here in that direction there, with the center off here by an eighth of an inch, allowing for the radius of the cutter. Okay, now that's important because we need to keep that in mind. We only have to follow the profile line around here now to get this correct. Now, we've got that right. Now we need to be in GO2, which is the GO3, which is counterclockwise. We need to be in a clockwise direction, arcing around here to the next point. So that will be GO2, or 0, 2. Enter. And we need the coordinate points, and I'll show you where they are. We need the coordinate points, which is actually here, but it is there it is there, the line there. It is 0.919 to that point there, which is the same in the positive direction of Y. And it's 158 thou from the 0 point there to that point there, and the radius is 0.932. So let's put that in, and you'll see the arc swing around. Now, if you get it wrong, you'll just muck it up. And now, sometimes the radius is the wrong way around, and the radius goes this way and not the other way. If it goes the wrong way in radius, you can put a 0 in the front, a negative in front of that, and the radius will swing around this way. Just have a look here. I buckled right around the other way, so did the wrong thing there. It's a negative. Sometimes it's just, we'll just update that. There we go, back to there. If you change it to a GO2, which runs the other way, a 2, it will spin back the other way. There's a GO2. This is a GO3. And of course, our next one is a GO2 because we're swinging clockwise. GO2, and we'll put in the coordinates like I mentioned before. Coordinates, our finish point, is Y. Y 0.92. And X is 0.16, and the radius R 0.93. Let's see what that does. There we go. Let's view that. Now let's view that from the top. Now we've seen, let's view this from the top looking down. We see here now we have our cutter coming around here, and now we want to be in a linear interpolation following a line down here. So now we need to be in GO1, which is linear interpolation. So we go enter, G01 for linear interpolation, and remember our feed rate is 1 inch. It's modal. Every time we select anything different here, we've still got the feed rate exactly the same. So we need to feed up to this point here. We need to go down to that point there, and the intersection point is the same, only it's on the other side here. It's 0.419 to that point there, and the arc point is this one here, which is 3.072, which is that point there, but we can just mirror that to the other side. So one's be a positive and a negative size there. So let's go back to our part. So what we want to do is GO1, which we are, X 3.7 y 0.42. See what that does. Hit that button there and just see that. So now we have our cutter now coming down in a straight line, linear interpolation, and now we need to swing all the way around to the other side. Now this time we did from y0 around to here. This time we need to go from y positive to y negative. So we run now. We're rotating clockwise again, like we did here. So that is G02 again. We're in G01. Now we need to be back in G02. G02. We need to be in y negative 0.42, and we don't need to worry about the x because it's redundant because we already have that there, but I could actually put that x 3.7 there as well, but I'm not going to. We don't really need it. We're just going, it's already in that dimension there. It'll just come over to here. We need to put in the radius of r 0.43, and we'll update that. Let's have a look at that. There's our round here, and now what we need to do is the same thing here as that one. We need to be back in G01. So that is that previous line there. Let's just copy that line because that line there is just this line mirrored to the other side. So if we go this line here, no, it's not that line there. Let's just type this in. I might muck it up. So let's just go, we're in G02. We need to be back in G01. G01. We need to be at this point here, which is the point x.16, x.16, and the y is a negative 0.92, y negative 0.92. That should work. Now we've got an error here. We've got an x and a y here, so that's the problem. We got an x, two y's. That's a syntax error. So we'll do that again, see how we go. There we go. And now what we want to do is swing this around to that point there. So we're still going G02, which is around this y here. We're going G02, y will be 0, y 0, and x is 0.93, x 0.93. Something's wrong with that. 0.93. Oh, we haven't got an R value because I didn't put the R value. See, it's picking me up. R 0.93, which is the radius. Click on that again. Now I've gone the wrong way. What have I done? This is a negative figure. We've gone to that point there. It should be that point there. It's a negative x, so we'll put in a negative there. Let's do that again. There we go. There's our profile done. No problem at all. Now, it's gone around one time 25 thou deep. Let's just view this in 3D again. We're down a little bit. Let's go back again. We need now to go down in Z. We're G02. We need to be back in G01. G01. Z. and with this don't forget we're absolute, Z negative 0.05 or 50 thou down here again. So we should see that little line coming down there of our cutter coming down to that point there, which we do. Now, rather than write all this over and over again, we're going to cheat a little bit. We have here, we've done this point here, we've gone to that point there. Everything here, from here on down, we want to copy. Apart from that, we'll go copy, right click and down here, and let's just paste that in. Paste. And we'll update that. Hopefully that will do what we want. And it has. Now, I'll explain what's going on here. We've gone down another 0.5, but our cutter's already, don't forget, our cutter is already sitting in the right spot, spinning nicely. We've gone around once. All we need to do was to follow that profile all the way around again, but 25 thou deeper. And that's what we've done here. We've gone to 0.5. And the next thing we need to do, with 0.5, we need to go with G02, we need to G01 again, G01, Z negative 0.75, and if we go enter and we just go paste again, paste the same profile over again. Let's have a look in the 3D. We've done something, we've gone 0.75, we should have gone 0.075, there we go. There we go, there's our next one. So now we are at 75 thou deep. And now we want to go Z, G, G01, linear interpolation, because we're in G, remember, we're in G02 from the last one. We need to be back in G01, Z negative 0.1, which is 75 thou last time, 0.1 or 100 thou this time. And of course we'll go enter again and we'll paste this thing again, right click and paste and update that. There's our third pass, and we've done something wrong here. What is it? Something's gone amiss. Let's just undo that. Redo that. Okay. What have we done? Oh, we've got X. We should have gone Z, you fool. Z. Down 0.1. So that's what's mucking that up. So there we go. And we'll come down here, right click here and paste. And that one there. There's our next one. Now we're at 100 thou. Now another 25 thou, and this will be through this part here. So we'll go G01 Z negative 0.125, which should break this part 3. We'll go enter and we'll put paste again, that same profile again. We'll update that. And there we have our cutter path going around here. Now, the simple thing to do now is just to come straight off. We can't sweep this back out the other one and turn cutter compensation on because it'll do a full depth cut sweeping around here. We don't want that to happen. We just want the cutter out of the way. So all we need to do now is we'll take off that M30 one there, which was changing things before. We're turning our spindle off. And now we're going to just go turn cutter compensation off. But at the same time, that's cutter compensation off there. I think we want to go just get this out of the way. Okay, we'll go G01 Z positive 0.1 this time here, and just get this back up out of the way by 100 thou. So we're just going to go there. It should just come off. There we go. There, we're up at that point there. And now we can basically shut this machine down GO4, turn off the spindle, turn off the color compensation, and send the whole thing back home again. And that is our program to cut the outer profile. And thanks for listening. I'm Mark Wilson, the Engineering Heretic.